So good morning dear students. Today we will be taking the same topic, the same formulas which we have seen in the previous video, and we'll do the questions of that type. Okay. But first let us see some proof. I heard that you are facing problem in some of the proofs. Okay. So let us do those proofs first. Okay. So this was the proof which I was telling. Sin 2x is equal to 2 tan x upon 1 plus tan square x. We are given with sin 2x. We know by the formula that sin 2x is 2 sin x cos x. Okay. Now we want the sin 2x formula in terms of tan x. So we try to make all the things in what? Tan thing. So what we are doing here, we have formula sin 2x as 2 sin x cos x. So very first thing which we are doing, I am considering this upon 1, and 1 by the identity we can write sin square x plus cos square x. Okay. Now what we can do, we want tan x. So I'm dividing the numerator and denominator by so what is tan x actually? This is sin upon cos. So if I divide cos square x, okay, so what we will get, that is 2 sin x cos x upon cos square x whole divided by sin square x upon cos square x plus cos square x upon cos square x, divided cos square x into numerator and denominator. So one cos with this one cos will cancel. Sin upon cos will give you tan. So 2 tan x upon this will give you tan square x plus 1, like that. Okay. Similarly, if you go for cos 2x, we have cos 2x one identity, that is cos square x minus sin square x. Now consider this upon 1. Again, what is that 1 we can replace with? We can replace it with sin square x plus cos square x, or cos square x plus sin square x. Now you divide numerator and denominator with cos square x. So numerator and denominator, dividing numerator and denominator by cos square x. So this cos square x upon cos square x will be what? 1. Sin square x upon cos square x will be tan square x. And in the denominator, you know, that is 1 plus tan square x. So that is how we have done this thing. Okay. And for tan 2x, you have to just use that identity, that how can you go for tan 2x? You can take tan x plus x and use tan a plus b identity, that is tan a plus tan b upon 1 minus tan a tan b. Okay. Alright. So let us see the questions, or what type of questions we have to solve for this formulas. The formulas which we have seen in the previous video of sin 2x, cos 2x, tan 2x formula, then all the formulas of this one, and sin 3x formula we have seen, cos 3x formula we have seen, tan 3x formula we have seen, and we have seen the half angle formula also. Sin x is 2 sin x by 2 cos x by 2, and similarly for cos tan. And we have seen that sin 18 degree and cos 36, cos 18, sin 36, that also. So let us do the questions on the same. Okay, let us do this question. It says that sin 2x plus 2 sin 4x plus sin 6x, you have to prove this is equal to 4 cos square x sin 4x. This is the question. Alright, so let us start with, let us take these two things, that is sin 2x plus sin 6x, because we can use sin x plus sin y identity in this one, and this is as it is. Okay. Now what is sin c plus sin d identity, or sin x plus sin y identity? That is 2 sin x plus y by 2 and cos x plus x minus y by 2. So 2 sin x plus y, 2x plus 6x, 8x by 2 will be 4x. Okay. And cos 2x and 6x, you can just change this one, or else cos 2x minus 6x will be minus 4x upon 2 minus 2x. So cos of minus 2x is what? Cos 2x only. So cos 2x plus 2 sin 4x. Okay. Now what you can do? you can take 2 sine 4x common. So in the bracket you will be having 2x plus 1. Okay. Now as you have one more identity, which is that identity that cos 2x is actually 2 cos square x minus 1. Take minus 1 this side. So if you take minus 1, so plus 1 will be there. So 1 plus cos 2x is 2 cos square x. So in place of 1 plus 2 cos x, we can put what? 2 cos square x. Okay, 2 2s are 4. So 4 sine 4x into cos square x, which is your required proof. Okay. Okay, let us take this question. It says 1 minus cos 2x plus sin x upon sin 2x plus cos x is equal to tan x we have to prove. Okay, so let us do this. As we know that 1 minus cos 2x is, this is, you just remember one thing. 1 plus cos 2x is 2 cos square x and 1 minus cos 2x is 2 sin square x. This is, we have discussed previously. The formula, actually the thing is, it is like this. I told you, no, the two formulas of cos 2x, 2 cos square x minus 1 and 1 minus 2 sin square x. So how I have understood this identity as, for 1 plus cos 2x, 2 cos square x, and for 1 minus cos 2x, we have 2 sin square x. That is how I have understood this identity. So 1 minus cos 2x we can replace with 2 sin square x plus this sin x whole divided by sin 2x. Again, what is sin 2x identity? This is 2 sin x cos x. Okay, so in place of this, 2 sin x cos x plus cos x. Alright, now see, from the upside you can take sin x common. We are left with 2 sin x plus 1, and from the denominator you can take cos x common to get 2 sin x plus 1. They two are cancelled easily. Sin x upon cos x is what? Tan x. So that is how we got tan x. Okay, let us see this question. It says cos x, cos 2x, cos 4x, cos 8x is equal to sin 16x upon 16 sin x. Okay, so it seems somewhat complicated, but this is really not a complicated one. Okay, so what logic we are going to use in this question, just try to understand that and use it in the questions of such kind. Okay, I'm not going to take LHS now. I'm going to take RHS first. Okay, so let us take RHS, that is 60 sin 16x upon 16 sin x, and let us prove that this is equal to this thing. Okay, sin 16, can we write this sin 16 as sine of 2 into 8x, 2 times of 8x upon 16 sin x, which is going on. I've written 16 as 2 into 8x. Alright, now the identity which we know of sin 2x, that is sin 2x is equal to 2 sin x cos x. Okay, so sin 2 into 8x, so 2 sin 8x into cos 8x. Okay, are you understanding? We have written sin 16x as sine of 2 into 8x. What is sin 2x? 2 sin x cos x, whatever here. So sin 2x is 2 sin, that is 8x and cos 8x by the identity, and the 16 sin x which is going on. Alright, now again what we can do, we can write this 8x as 2 into 4x, can we? Okay, then again use the identity of this. We can do one thing, you can cancel this with 8. Okay, so we can write 8 here. Okay, so this 2 won't be there. So here sine again 2 into 4x, so 2 sine 4x cos 4x by the identity of sine 2x, sine 2 theta, 2 sine theta cos theta, cos 8x upon 8 sine x. Again you can cancel this with 4, so sine. Now this 4x, again you write 2 into 2x. So what you can write this sine 2x as 2 sine theta cos theta into cos 4x is going on and cos 8x upon 4 sine x. Okay, so this 2 with this 4 you can cancel by 2. Okay, now again you are left with sine 2x, so just put 2 sine x cos x identity into this cos 2x into cos 4x into cos 8x whole upon 2 sine x. Now you directly cancel this 2 sine x with this 2 sine x to get cos x, cos 2x, cos 4x and cos 8x. Hence prove. Okay. Now please, this is the question we are going to take and you have to focus in this question very sincerely, because if you understand this question, because you know this condition like mostly comes when you go to 12th class. So such type of condition we used to get in solving the inverse trigonometric questions or differentiation question. All right, so we use such criteria, that means step. So please focus here that how we can prove under root 1 plus sin x upon 1 minus sin x is equal to tan pi by 4 plus x upon 2. Okay, the very first thing which I'm doing, I'm replacing this sin x and I'm using its formula, the half angle formula. As I told you that sin 2x is what? 2 sin x and cos x. So if I divide this angle, I need to divide this and this also by 2. So here what we are getting, sin x. So sin x is 2 sin x by 2 and cos x by 2, that is we already discussed. I told you the half angle property or half angle formula already. Okay, so under root 1 plus, in place of sin x I am writing 2 sin x upon 2 and cos x by 2 upon 1 minus 2 sin x by 2 cos x by 2. Okay, then see what we are doing. We can see, I'm writing this one as, by the identity we know that sin square theta plus cos square theta is equal to 1. Okay, or sin square x plus cos square x is equal to 1. But you know, as this is equal to 1, if I divide this angle and if I divide this also, this is also equal to 1. So sin square x upon 2 plus cos square x upon 2 is equal to 1. So in place of 1 we are writing sin square x upon 2 plus cos square x upon 2 plus 2 sin x by 2 cos x by 2 whole divided by, in place of this 1 we are again writing sin square x upon 2 cos square x upon 2 minus 2 sin x by 2 and cos x upon 2. Okay, now if you see the numerator, isn't this looking like a plus b the whole square identity, where your a can be cos x by 2 and b can be sin x by 2. If you expand cos x by 2 plus sin x by 2 the whole square, so what you will get? Cos square x by 2 plus sin square x by 2 plus 2 sin x cos plus 2 sin x by 2 cos x by 2. And similarly in the downside you are having cos x by 2 minus sin x by 2 the whole square identity in the denominator. So what will happen, this to the square, this will be whole square and this square with this root will be cancelling. Okay, so what we can do, I'm just rubbing this root. So finally what we got as cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x upon 2. I hope you understood till now. So I hope you understood till now that we numerator we have written like this. That means the whole square and denominator the whole square. This the whole square and root are cancelled and we are left with this thing. Okay, now you understand that after this step what will happen. Okay, now in this step what I'm doing, I'm taking I'm dividing the numerator and denominator by cos x by 2. Okay, so dividing numerator and denominator by cos x by 2, because I want this thing to be in tan. That is why we are dividing it by cos x by 2. So let us divide. So on dividing the numerator by cos x by 2, this will be what? 1 plus sin x by 2 upon cos x by 2. See, cos x by 2 upon cos x by 2 will be 1 plus sin x by 2 upon cos x by 2 will give you tan x by 2. Okay, upon 1 minus, see, this will also be 1 because cos x by 2 upon cos x by 2 1 minus, and this will give you tan x by 2. Okay, now see how we can mold, how can we get this thing from this thing. Now please understand this thing also very importantly. 1, can we write this 1 as tan pi by 4? Because pi by 4 is 45 degree and tan 45 degree is 1. So in place of this 1 I am writing tan pi by 4 plus tan x upon 2 whole upon 1 minus, this is actually 1 into tan x by 2. So this 1 I am replacing it with tan pi by 4 into tan x by 2. If you won't understand, then you understand it like tan pi by 4 is what? 1, and this tan pi by 4 is 1, so 1 into tan x by 2 is what? Tan x by 2 only. So I'm writing this tan x by 2 as tan pi by 4 into tan x by 2, which is this only, because tan pi by 4 value is 1. Now isn't this an identity of tan a plus b? Because tan a plus b says tan a plus tan b upon 1 minus tan a tan b. So this is tan a, this is tan b upon 1 minus tan a tan b. So this is this whole is an identity of tan pi by 4 plus x by 2, and hence this is proved. Now I will explain you an alternative method for this one. Okay, so this is the alternative method. See, I've rationalized the denominator to get 1 plus sin x upon 1 minus 1 plus sin x, because 1 minus sin x was there, so rationalization will be 1 plus sin x upon 1 plus sin x. So this 2 will become the whole square, and a minus b and a plus b, a square minus b square. Okay, so 1 square minus sin square, which is 1 minus sin square. So this is square, 1 minus sin square is cos square x. So 1 plus sin x upon cos x the whole square we can write. Okay, now this square and root will be cancelled and you are left with 1 plus sin x upon cos x. Now as I explained you previously that 1 can be written as sin square x by 2 plus cos square x by 2 plus this sin x can be written as 2 sin x by 2 cos x by 2. Okay, and upon cos x I'm using the identity of that cos 2x. Cos 2x, one identity is there, no? Cos square x minus sin square x. So what will be cos x from here? This will be by the half angle formula. This will be what? Cos square x by 2 minus sin square x by 2. Okay, now in the numerator can we write this as cos x by 2 plus sin x by 2 the whole square upon, and this is what? This is actually a square minus b square identity. So you can write it as a plus b and a minus b, like this. Now what you can do, this cos x by 2 plus sin x by 2, you can cancel it with this one and you will get this step. So, cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2. And if you remember, this step we got in the first alternative case, the one which we solved, that means for the first, no, we got this step on solving that one. So you just go, if you want to understand again, then you just go back and watch that how I have solved from here to prove this one. Okay, let me give you some hint of some of the question which you can do, which you have to do by your own. That means to find the value of sine 4x, as we have sine x value, as we have sine 2x, sine 3x, so we can deduce sine 4x also. How can we find this 4x? I'm writing this 4x as 2x plus 2x. Okay, can we write? Yes. Now this by the identity of sine x plus y, we can solve this question. What is sine x plus y? This is sine x cos y plus cos x sine y. Now what you want? You must have sine 4x in terms of sine only. So what will be our mindset? Our mindset should be like this cos and this cos should be removed. Okay, this cos and this cos should be removed, or else you can see they two are same, so you can write 2 sine 2x and cos 2x, or like you would have used the simple identity that this sine 4x can be written as sine 2 into 2x. So sine 2 theta is what? 2 sine x cos x. You would have done this also, and that is also correct. Sine 4x can be written as 2x plus 2x, and using that sine x plus y identity. Now this cos 2x, can you replace it with 1 minus of 2 sine square x, right? Okay, so we have replaced this cos 2x as 1 minus 2 sine square x. Now again you can replace this sine 2x with 2 sine x cos x. Okay, and then just keep on solving it, you will get the answer. So similarly your assignment will be on finding the value of sine 4x, cos 4x, and just wait, cos 6x and cos 5x. This 4 questions you have to do. Okay, just please listen here. See, as I told you right now that sine 4x can be written as sine 2 into 2x, and this I have written as 2 sine 2x cos 2x, and this cos 2x I have written as 1 minus 2 sine square x, and this is as it is. And I told you that you can again change this sine 2x as 2 sine x cos x. Till now correct, but as in this cos is coming, and after that means we have to remove this cos x also. And we have cos x formula in terms of like the half angle formula, so it would be very complicated for us to solve after this one. So you do one thing, what we can write this 4x as, you can write this 4x as sine x plus 3x. Now you use sine x plus y identity here, and that is sine x cos y plus cos x sine y, and then you use the 3 formula, that is sine 3x and cos 3x, that means whatever we have. Okay, and then you try to solve it. Okay, so that's it for today. I hope you understood the things which I taught you today, and just try to do more and more practice, because without practice you cannot do anything. The only way to learn mathematics is to do mathematics. Okay, so you have to do it. That's it for today. Thank you so much.